Hey guys, I'm going to go over the 8.1 homework. Just going through some trigonometry, sine, cosine, tangent, cosecant, secant, and cotangent. First thing that I'm going to need to do with question 1, if I'm going to get all 6 trigonomic functions, I'm going to need to find the missing side length right here, and I can do that by using Pythagorean theorem. So I can say 9 squared plus 12 squared will equal c squared. So 9 squared plus 12 squared is going to be equal to 225. So 225 is going to be equal to c squared. And I take the square root of that, and I get 15 as the hypotenuse. And then we're using theta as our angle. And sine of theta, well, if this is the theta angle, then this side is the opposite to theta, and this side is the adjacent to theta, and this is the hypotenuse. And sine is opposite over hypotenuse, and so this will be equal to 12 over 15. Cosine is the adjacent side over the hypotenuse, and so this is going to be equal to 9 over 15. Tangent is equal to the opposite over the adjacent, so that's going to be equal to 12 over 9. And then as for cosecant, cosecant is reciprocal to sine, so this is going to be hypotenuse over opposite. Secant is reciprocal to cosine, so this is going to be hypotenuse over adjacent, and cotangent is reciprocal to tangent, so adjacent over opposite. So cosecant will be 15 over 12, secant will be 15 over 9, and cotangent will be 9 over 12. Again, just reciprocal to their others. Okay, and then for 2, likewise, we need to find the missing side. However, this is not the hypotenuse like it was in the previous example. And so when I set up Pythagorean theorem, it's 7 squared, or I guess I could say 5 squared plus b squared is equal to 7 squared. So b squared will be equal to 7 squared minus 5 squared, which will be equal to 24. And b will be equal to the square root of 24. But that's also equivalent to the square root of, let's see, 4 times 6, I guess you could say. 4 times 6, which would then be equal to 2 root 6. Yeah. And so keep that in mind. This side is 2 root 6. Since this is where theta is, this will be the adjacent side. 5 will be the opposite side, while 7 will be the hypotenuse. And sine is opposite, so over hypotenuse, so 5 over 7. Cosine is 2 root 6 over 7. And tangent is equal to 5 over 2 root 6. However, don't leave this radical in the denominator, so we're going to rationalize the denominator. We're going to multiply the top and bottom by root 6. So that's going to make the numerator 5 root 6, and that's going to make the denominator 2 times by 6, which will then just be 12. All right, moving along, cosecant reciprocal to sine, so it's going to be 7/5. Secant is going to be 7 over 2 root 6. However, we're going to multiply the top and bottom by root 6. And so that's going to be equal to 7 root 6 over 12. And cotangent is going to be equal to 2 root 6 over 5. So using the reciprocal, I'm just using the reciprocal of this one, because, I mean, they're both equivalent, but if I use the reciprocal of this equivalent form, then I don't have to rationalize the denominator. So, yeah, I think that should be it for that. All right, now in this case right here, it gives us one of the 6 trigonomic functions, and we need to find the other 5. Now we're going to draw a triangle. So we have to keep in mind that cosine is equal to the adjacent side over the hypotenuse. So if I draw a triangle, I'm going to draw the triangle with the hypotenuse length of 12 and the adjacent side length of 5. So maybe draw it like this right here. So the hypotenuse is going to be 12. The adjacent side is going to be 5. This means that this is the angle. It has to be theta, since I made this the adjacent side right here. So this is the adjacent side. This is the hypotenuse. We have to use the Pythagorean theorem to find the other side. So I'm going to do 12 squared minus 5 squared, which is 119, and take the square root of that. That's going to be equal to the square root of 119. Now, square root of 119, I don't know if 119 has any, let's see, let's divide 119 by, I don't think I can simplify that. I don't think 119 has any factors that are perfect squares, so you can't divide it by 4. 119 is not divisible by 16. Is it divisible by 9? Nope. 119 divisible by 49. 119 divisible by 64. I don't know. That's not okay. So I don't need to simplify that. So sine of theta is going to be equal to square root of 119 over 12. Cosine we know is 5 over 12. Tangent will be square root of 119 over 5. Cosecant is going to be 12 over square root of 119. But then as you rationalize the denominator, that's 12 119 over 119 when you multiply the top and bottom by square root of 119. Secant is going to be 12 over 5. Cotangent is going to be 5 over square root of 119, but I multiply the top and bottom by square root of 119, so that becomes 5 square root of 119 over 119. All right, for cosecant, likewise, we're going to draw another triangle. Remember that cosecant is reciprocal to sine, so this is going to be the hypotenuse over the opposite side. So should have drawn it like this first. Okay, I'll go ahead and make this theta right here, which would make this side right here 8 and this side right here 5. So this is the hypotenuse side, and this is the opposite side, which makes this the adjacent side, and I need to find the adjacent side. So I'm going to do 15 squared minus 8 squared, and take the square root of that. Well, it's 161. So this is square root of 161. 161, is that divisible by, I don't think that doesn't look like it's divisible by any perfect square that I know of. So, all right, so sine, that's just like a weird number. Square root of, comes out to be 12.68, but we'll keep it at square root of 161. All right, so sine is going to be equal to 8 over 15, which makes sense because that's reciprocal here. All right, cosine is going to be equal to the square root of 161 over 15. Well, tangent is going to be equal to 8 over square root of 161, which will be equal to 8 square root of 161 over 161. Secant is going to be 15 over square root of 161, which will be equal to 15 square root of 161 over 161. Cotangent will be square root of 161 over 8. All right. Now, moving along to these three right here, find the value of x for the right triangle. All these right here are special triangles, special angles, 60 degrees, 30 degrees, 45 degrees. So if you remember that in a 30, 60, 90 triangle, the ratio between the shortest side, which is what this is, so if this side right here, if this angle right here is 30 degrees, opposite to the 30 degrees is the shortest side in this triangle, and the shortest side has a ratio of 1 to 2 with the hypotenuse. So meaning that the hypotenuse is always double the length of the shortest side. And so if the hypotenuse is 6, that means the shortest side has to be equal to 3. So that means x is going to be equal to 3. And just, it's not part of the question, but that would also make this side, the longer leg, equal to 3 root 3. It's always root 3 times larger than the shortest leg. All right, here we still have a 30, 60, 90 triangle. So this right here would be 60 degrees. We're trying to find the length of the shortest leg right here. We know that the hypotenuse is 13, and that means that x has to be equal to half of that. So that means that x is going to be equal to half of 13. And then as for 7 right here, we have a 45, 45, 90 triangle, and the ratios between the legs are 1 to 1. So that means that x has to be equal to 7. The legs have to be the same length. All right, now here in these problems, it's just using your calculator. So cosine of 14, well, that's pretty simple. You can just go to your calculator, type in cosine of 14. And 1 second, I actually have to make sure that I am in degrees. So cosine of 14, and I got that this is equal to 0.970. 0.3, I guess, if we're rounding to 4 decimal places. If you did not get this and you know that you typed in cosine of 14, well, let's see right here. If the only other thing that I think you could have gotten in your calculator is, well, actually, let me type this in red, is equal to 0.1367. If you got this, this is wrong. It means that your calculator is operating in something that we call radian measure, and you want to make sure that your calculator is in degree measure. There's usually some sort of setting in your calculator that you can switch between degrees and radians. So if since this angle is given to us in degrees, then that's what you should expect as your answer. Okay. As for the next one, your calculator most likely doesn't have a button or an operation of cotangent, but you have to remember that they are reciprocals. So cotangent, cosecant, secant are reciprocals to the other three. And so whenever you're typing this into your calculator, type it as 1 over tangent of 6 degrees, and that's how you can get the reciprocal value of it. So if you do that, so 1 divided by tangent of 6 degrees, I've got 9.51, 4, and 4. And I think that should be it right there. Okay. Solve the triangle using the diagram and the given measurement. So solve the triangle means to find all values. So it tells us here that angle A, so this angle right here is 55 degrees, tells me that side length A is 17. We already know that this is a 90-degree triangle, so we're going to solve this triangle right here. We need to find angle B, side length B, and side length C. So I think the easiest thing to find right now would be angle B. So because we know that the two acute angles have to add to be 90. So if you do 90 divided by 55, or sorry, 90 minus 55, you get that B this has to be equal to 35 degrees. So we'll say 35 degrees for angle B. Now, as for the sides, I'm gonna, since we only have one of the three sides, we can't use Pythagorean theorem. So I'm going to use a trig operations. So now it doesn't really matter, since we do know angle A and angle B, we can pick either one. Now, if I pick angle A, that means the one side that I have is opposite. So if I'm using angle A, I have to use tangent or sine in order to solve for either B or C, and I can do both. If I want to use angle B, I would have to use either tangent because I have the adjacent side, or cosine. So again, angle A, the side that I have for angle A is its opposite side, so I'd have to use tangent or sine. For angle B, if I want to solve for B or C, I would have to use tangent or cosine. So solving for tangent will solve for B. Solving with tangent will help me find angle side B. Solving with cosine with angle B will help me find side C. So hopefully that makes sense. And if I use angle A, if I want to solve for B, I have to use tangent. If I use angle A and I want to solve for C, I have to use sine. So I'll just stick with A, and I'll say let's do sine of 55, which means I'm solving for C. So sine of 55 degrees would be equal to 17 over C. Now, C is in the denominator, and this is what I want to find. So I have to multiply both sides by C. So I'll get C times by sine of 55 equal to 17. And then I have to divide by sine of 55. Divide by sine of 55. So I'll get C is equal to 17 divided by sine of 55 degrees. And you can go ahead and punch that into your calculator. So we're going to do 17 divided by sine of 55. And I get that C is equal to 20.75. I'm just going to round to 2 decimal places. So C, 20.75. Now for B, I can now use Pythagorean theorem. But because I'm rounding this side right here, that also means that B is going to be even a larger or even greater rounding error. So I'm just going to stick to using trig functions. But this time I'm going to, let's say that I use B, and I'm going to use tangent. So again, I have a lot of different options available to me. So tangent of, we'll say 35. That's going to be equal to B over 17. And this is nice because unlike in this problem right here, where my ratio set up the problem with C in the denominator, well, this one, tangent 35, actually set my unknown to the numerator, which is nice because then I can just multiply by 17. And so I get B is equal to 17 times by tangent of 35. So 17 tangent of 35 is going to give me 11.90. 11.90. Now, you guys might think, well, wait a minute. These don't look like they're proportional, and they're definitely not. So don't try and read them as they're proportional, okay? Or that it's to scale, I guess I should say. All right, for 11, we'll do something similar. So I know that B right here is 72 degrees. Well, that's going to make 90 minus 72 degrees the other angle, so that's going to be equal to 18 degrees. So angle A is 18 degrees. I'm going to use some trig. I like to set it up in a way where the unknown is on the numerator. So let's say wait a minute. Let me go ahead and write in what I know. So C is 12.8. Let's see. Is there a way where C is in the denominator? The hypotenuse is in the denominator. Yes, we've got sine and cosine. Oh, wait, but I don't want c in the denominator, do I? That's the point. Oh, wait, no, I do, because I know it. So let's say I take sine of 18 degrees. So sine of 18 degrees would be equal to a over 12.8. So then I'd have to multiply by 12.8, and I get 12.8 times by sine of 18 as side A. So 12.8 sine of 18. And I get that A is equal to 3.96. So 3.96. Let's say I use sine of 72, and that would give me b over 12.8. So then b would be equal to 12.8 times by sine of 72. So 12.8 sine of 72, and I get 12.17. 12.17. Okay, I think that's good. I kind of feel like that's a little too close to that. We do know that C has to be the longest side. All right, but I think that... Okay, we'll call it good. All right, let's see, we got these two story problem questions. So to measure the width of a river, you plant a stake on one side of the river directly across from a boulder. So you got the boulder right here, and you're planting your stake right here. You then walk 100 meters to the right of the stake and measure a 70. So you walk to the right, you measure a 79 degree angle between the stake and the boulder. What is the width of the river? So you don't know the hypotenuse side. This is the hypotenuse. You want to find the opposite side, and you have the adjacent side. So you have this angle with these sides right here. You don't want to use the hypotenuse. So I think we want to use tangent. So if I use tangent of 79 degrees, that's going to be equal to W over 100. So W will be equal to 100 times by tangent of 79 degrees. So 100 tangent of 79 degrees is equal to 514.46 meters. So that's the width of the river. All right, you are standing on the Grandview Terrace viewing platform at Mount Rushmore, 1,000 feet from the base of the monument. You look up at the top of Mount Rushmore at an angle of 24 degrees. How high is the top of the monument from where you're standing? So you're trying to find this side. So I think you're going to set up the problem in the exact same way. So, oh, wait a minute though. Assume that your eye level is 55 feet above the platform. So I guess we do need to do some adjustments here. So we have... Let's see how this works out right here. You look up how at 24 degrees. So I think this angle right here is 24 degrees. The whole length right here is B. So we'll call this side length X. The X length that I'm referring to is this right here. And I know that this length right here is 5.5 feet. All right, and I know that this is 1,000. So if I use tangent of 24 degrees, that's going to be equal to X over 1,000. So x is going to be equal to 1,000 tangent of 24 degrees. So I get that x is equal to 445.23 feet. But the how high is the top of the monument from where you are standing? So standing would be here. So then we found x, add 5.5. So plus 5.5 feet. And you get that the actual height, we'll say b, is equal to 450.73 feet. Okay, and that should do it for 8.1.